Start at one, I guess.
Okay.
And yeah, you can have some intro time.
Yep. Okay. So today we're going to talk about female Triepeolus. We're using a Discover Life guide as the basis. We will bring up that much of the Discover Life material in there is actually from Molly Reitmeyer's revision of Triepeolus, which occurred a number of years ago now, but had wonderful illustrations and lots of detail. And I'm going to share my screen. And I believe that Claire, did you send out a PDF of that revision to everybody
I sure
or a
did.
link? Okay. So if you look at that, the guide, her guide works well, but it's a, hang on, let me just share my window. It has the issue that it covers all of North America and Central America at once. So you have to claw through a lot of things, which is fine. And if people like dichotomous keys, it's basically the same information presented in a dichotomous fashion rather than on Discover Life in a non-dichotomous. So people don't have that key handy. Here's the key to females of North and Central America from Molly. Really, really well done revision and lots of good information within the species accounts, all of which we've imported, or at least the Eastern ones we've imported into Discover Life too, so you can read them there also handy, and lots of pictures. So I'm not going to use Molly's guide because we'd have to move through, like, if you look on this first page here, many of these are Western species that, or super uncommon like Balteatus that we don't have. So what we'll do today is jump over here to the Discover Life guides, and we'll go here to the start, and we'll cover a lot of the characters, and then we'll get into some species pairs, but mostly it's an introduction to how to think and look at Triepeolus females, which are a little bit different from many of the things that we talked about before. So I think most of you are aware of how to use Discover Life guides. I'll point out that the green numbers here again indicate how many, in this case, female Triepeolus, because this guide is only to Triepeolus female, are scored for that character. So Nebraska 16, Massachusetts 11, and so forth. And that's going to be useful when you look at the characters and sort of install in your mind that if you see an unusual character, that's going to be very helpful because it'll eliminate most of the others right away. So paying attention to what the little green numbers are going to be helpful as you go through these kinds of things. Because when you see, for example, that there are no scutum hair bands at all, that really narrows it down to a small number, or you have this fuzzy indistinct one. We're going to talk about these. So I just wanted to point out these things. So starting with number 2 here in the Discover Life system, we're confronted with color. So color in Triepeolus and many other species where you have something that is reddish, so that can be an orange, an amber, a bright red on a piece of the anatomy of the bee, often is a little problematic. So if it's completely black to brown, that's solid, right? There's nothing there. But a lot of times it's not completely red, orange, or amber. You have, and it says here, primary integument color. But sometimes you have a bit of red, or you'd be like, I'm not 100% sure if that's primarily red or primarily black. So in that case, you could score them for both, but that doesn't really do anything because you're basically saying it could be either of these. That means everything's going to stay the same. You could pick one or the other. That is not the right approach because now you're guessing. So if you're in that state where it's like, I could go either way on that, then there is a strong likelihood that whatever that species is was probably scored for both two, and but the the best approach is don't use the key for don't use this character if there's ambiguity. And color often brings with it ambiguity because a lot of times you get a partially red or reddish kind of thing going on. So if we look here, so these are really nice characters because they're pretty discrete. You look at the pronotal lobe, is it black or brown, or primarily black or brown, or primarily red, orange, or amber? If it's ambiguous, skip it. Same thing here, thorax, primary integument color of tegula. So again, in many cases, it's pretty darn obvious. You do have these in between. Again, this is a character to skip if you're not sure what the color could be classified as because there's too much of a mix. And then we get, but the color is so useful, we've put them near the top, right? Because it helps you split things out pretty quickly. So here again, legs integument color, and it's saying to ignore the tarsal segments, the coxae spines, and you have now a little bit more choice because we allow for some ambiguity. So we have the much rarer case, the only 12, entirely and distinctly red or orange. Some really are all red, and that's when you see something like that, usually that's obvious, and usually that's going to help you narrow down your list quite a bit. And then you have some entirely brown to black, and then a bunch of them have a mix of colors. But you can see by the split between these that it's quite evenly had. So I must have, so I have something listed as only 7. I must have, I'm sorry, I'm going through here. Oh, you know what? I'll just restart the whole thing. So I had something scored in there. There's 29 species involved in this particular key. So when we look at these, you can see there is overlap. 13, 19, 12 does not add up to 29. And some are scored for more than one thing, as we would want to be conservative. So now we get to another useful character is like what's going on in the scutum. So Triepeolus as a class has lots and lots of oppressed hairs. Let me just open up just a nice picture of a Triepeolus so you can see these. The same thing would be true of Epeolus and Epeoloides, that group of bees, whatever the super classification of those are, all have these bandings of oppressed white hair. So by oppressed, I mean they're lying down, they're prone, and they're actually made up of many, many branched hairs that make them, I call them little fat hairs. So let me just pull up our pictures are often better than using the microscope, just simply because they they have more detail. So if we look at these kinds of things, this is a little ragged and rough here, but these are the kinds of hairs that we're looking at, which are very small, fat, in that they're wide because they're, if you actually looked even closer, you'd see that they're branched in many ways, and they're lying down on the integument, and they form these lovely bandings of hair. So just the vibe from these will tell you that you're looking at Triepeolus. And then the patterns of those hairs are often extremely useful in determining species. So here, for example, we're looking at T2. We'll come back to this. Here, this arm coming up, the angle of that arm is different in different species groups. The length and width of that bare spot on T1 compared to the sides is often quite different. So let's jump back, guide, and here we go. So here, what we're looking at is we're looking at the thorax, and we're asking what's going on the thorax with the bands of white hairs that are subparallel. So is that subparallel? Is that right? So they're parallel. No, they are parallel to one another. I guess submedian. So here's a median line. So they're either side. They're almost always in that area. And then there's a couple states. One, are they completely absent? Note, sometimes you have specimens that are goopy, particularly if you have collected them in a kill jar or that has lots of moisture in it, or you have collected them in a solution of propylene glycol and in both cases not clean them well afterwards. So those white oppressed lines will turn dark as all hairs do if they're matted and covered with goo. And then it can look like they're not there. So be careful. Usually you can figure it out. You can see that, oh, if I'm looking here carefully, I do have white bands. They've just been distorted by bad processing, let's say. So so you have the absence, that's one set of species. You have two bars here that are just floating in space. So they're not connected to white hair along the edges. So let's see if we can drill in here at least a little bit fuzzier at this level. But let's critique what's going on here. So this area right here looks like a white band that they might be connected to, but it's actually not part of the scutum. So the scutum boundary is literally right there at that hard, dark, light boundary. This is the pronotal collar. So this is part of the pronotum, big thing that the head sticks into, and it's almost always got white hairs across it. But we're not talking about that. We're talking about the scutum. So it may look like these white bands connect to a big white bar on the scutum, but they don't because that white bar is not on the scutum. So that's the state of two white bars, but without any kind of connection to another set of white on the scutum. So here is the presentation of two white bars, but they're connected to, which could go all the way across in some species, but they're connected to white hairs on the scutum. You can see the white hairs all throughout here. And take a look at that number 10. It's not a super common character. Neither is the absence. And also when we get to this last one, there's only 3. Most of them have a pair of white bars that are just floating in space. Almost all of them, as a matter of fact. And there's lots of overlap between some of these categories. So this is the one where there's a connection. And then the last one is where it's really difficult to tell whether you have a connection or not. The two that come to mind here are a Savastra specialist. So most Triepeolus are Melisodes specialists. So Savastra, as Don, who I'm not sure he's on the line here, recently told us, and according to a USERA revision, or at least molecular investigation of USERA, Savastra is now, I believe, considered to be part of, well, I shouldn't say, is it part of Melisodes or USERA? But it kind of has disappeared, which makes me a little leery about a lot of these molecular things because they're now crossing over each other in terms of their advice as to what is and isn't a genus or a subgenus and things along that line. The identification stream is still going to be the same to the species level, but we have some name shenanigans going on, and it'll stabilize at some point. Anyway,
But Sam,
this
question.
Yeah.
Like just as like a point on that, like, I mean, but so our characters will stay the same, but we're gonna have to rewrite whole guides and like, you know, find new ways to squeeze these into other dichotomous situations. If
Well,
like it's not
yes,
it's not gonna be like we're gonna still have the
well,
same things that we can do though to look at them.
yeah. So there's a couple ways. One would be, let's say we're dealing with Savastra and it's now considered to be Melisodes. We could have a guide to the Savastra still. First of all, I haven't looked into it, so I don't even know if all the Savastra are going there or not, but let's just say all the Savastra are now considered to be Melisodes. So we could add them to the Melisodes key, or we could say Melisodes Savastra group and basically just keep them in their own little key for now. But we will have to do that. But we also wait until we see what John Asher does, because sometimes he disagrees and doesn't make the changes to the genus level. So we go with John because we consider him to be the authority we follow, and we don't want to have to be making decisions ourselves on taxonomy and names. We just use his convention. And frankly, there is sometimes not a right or wrong here. It's just we're following a particular person's convention on taxonomic names, and usually that means at the upper level. So, so I wish it were like rock solid, but I think this we'll expect more of this as more and more molecular work gets done. In any case, this group, so most of these Triepeolus are nest parasites on Melisodes, but a number of them kind of sneak around. So this one is a Savastra. I think that's concavus. And then the famous Pepinapus parasite is remigatus, and it also has this sort of indistinct pattern. We'll get to it. It looks like a boat anchor. Is that a boat anchor or is it some? I can't remember. I think boat anchor was a description, but someone else has some crazy. It has some other like the Ukrainian national flag or something. But we'll uh, let's backtrack. Okay. So those are good characters, separates things out. If you have things that are not just floating single bars, then you probably can eliminate quite a few species that way. Then we get to more shape of the oppressed hair patterns. In this case, we're going to T1, so the first tergite on the abdomen here, and we're looking at the shape of the internal dark area that's formed. Sometimes these come together, sometimes these don't come together. In other words, sometimes there's a gap there, sometimes there's not a gap there. And we're asking the question as to whether the lateral, I don't know if that lateral is the right name, but the latitudinal, that's probably better, latitudinal sides are parallel to one another or not. So here's two examples of not parallel. This one is roughly diamond shaped. You can see here, so that's not parallel. This one is more hammerhead shaped down here. So again, that line has no parallel partner to it. And then the other, so that's less common. You see 10 and 25. So many of them could be classified as having parallel boundaries, I guess maybe would be the word, to this dark internal edged area. And so the choice there is will help narrow things down again. And then the question is, well, what's the width of this area, of this dark area compared to the width of the bands to eat on the lateral sides of white hairs? So here, narrow and pretty easy to describe. Again, there's often overlap between these categories in any one species, but none of them, I believe, would go across all three categories. So here is narrow. So if you take a look at this one, clearly this dark area has a length or width, as you, depending on your orientation, of the dark area compared to the sides, with the dark area being smaller. So it's narrower. And then you have something that is roughly equal. So, and you look at the numbers 5 and 7. So these are less common states. Roughly equal is a tricky character. That's why anything that's roughly equal is usually scored also for the things on either side, because nature doesn't deal with equal, right? It's either a little bit bigger or a little bit smaller. So nothing is going to be exactly equal because the requirements for something being equal are very high. In other words, you can't depart from that equalness. But anyway, we have that category so that you can move to either side of it pretty freely. And if you have something that's about equal, don't expect it to resolve a whole lot of things. So if we go down to the next one, we get to these lateral swaths of pale hair on the lateral side. So we talked about that when we were looking at the one picture. So you're going to T2. So there's the boundary with T1. That's T1 above. T2 is here. There's the boundary, the bottom. This is a basal. No, this is an apical band of white hairs with a slight rim at the end of no hair. So we're just talking about these white hairs. And then if you look on the sides, this might kick up a little bit, but not significantly high. So it basically is just a band. And so there's no lateral sides, whatever. So it says lateral swaths of pale hair absent. Okay, and there's about 10 of them that could be scored that way. Again, a lot of these things will have overlapping membership in a particular species. Then the next one is that these hairs are square or obtuse. So again, we're looking at so now there are lateral hairs. Oh, I can see them. What's the angle between the apical band and this lateral band? And if we are lucky, well, it doesn't matter because we're saying square or obtuse. So square would be 90 degrees, as you can see here, just like a carpenter square, and obtuse would be this angle here would kick out like that. So it's greater than 90 degrees. And so if you have that, you would score it for there. We sadly don't have a weakly acute angle demonstrated, but it's defined by a set of degrees, so 60 to 80 degree angle. And we'll illustrate that here with the last one, strongly acute. In other words, you have the side bars of pale hairs actually curve back in. And so here it's illustrating one that this one is roughly 45 degrees, but 45 degrees or less. So you have this strong recurving portion, not some kind of big bar sticking up here, where it curves back, and that's at a less than 45. So again, usually a very good character. Every once in a while, you have a goopy specimen you have to watch out for where this banding disappears. Okay, now we get to a feature that a few bees have, but Triepeolus is maybe the queen of pseudopygidial areas. So by pseudopygidial area, I'm talking about on the last segment of the female in this case. And in this case, the last segment of the female has this area right here and it would be on every single one of the females that has modified hairs. Presumably that has to do with invading the nest of a Melisodes and somehow doing something with their rear end to form where the egg is going to lay. If someone knows, put the details into the chat. I'm guessing that's what most pseudopygidial areas are. It's some structural element to the abdomen that allows them basically like a hand to pat down something. So what you're looking at is the rim. So here it's actually slightly concave. And again, pretty sweet character because it's not something that's usually that ambiguous unless you're right at, is it concave or is it straight? So here you have convex. You can see here by that number, most things would fall into a convex category. The concave, relatively rare, only 4 species. Straight across would be the final one. Again, what is straight is a question that needs to be asked. And so so straight is obviously very tightly defined by geometry, but I found working with these specimens that indeed a lot of specimens can be clearly defined as being, oops, darn it. Hang on. What did I do here? Oh, here we go. That can be pretty easily defined as directly straight across. I'll point out that, as an aside, that pick has changed. We'll go to here. If we go to, I don't know which one, Distinctus here, that he's changed his picture system so that when you now click on it, again, instead of getting the super tiny little box, you get a much bigger box with more details that you can take a look at. So it's the picture handling is better now than it was. Thank you, Pick. So back to the game. What we're looking at, 3 different edges to the rim, and so you can classify those. And you can see again, convex is the most common of all of these. The next one.
Hey, Sam.
Yeah.
How challenging, like when you actually are looking at this, like how hairy are those edges? Like, are you having to look at them at a specific angle to like see the edge of the integument versus?
not
Hairiness.
challenging.
Yay.
I've always felt that it was very clear and I didn't have to struggle. So it's one of the better ones because usually the abdomen is not covered by a leg or a wing or something like that. Or if it's a wing is all the way back there, you can use a pin to move the wing and tuck it under the abdomen or something like that. So I haven't found it to be a problem at all. The next one is useful. And for some reason, I think because Molly had these, we don't have these characters. But what you do is you turn the specimen sideways, and you're looking at S5. So basically, the last of the segments. And we'll pull this one up here, and you're asking what's the shape on this segment. So straight. So in other words, it would be straight across, which you don't have illustrated here. Strongly turned down, where it's bent down like, it's curved over, it's not straight line. And then weakly turned down. Weakly, is an ambiguous term. So it is the kind of thing where if something is weakly turned down, it might also very well be scored for straight and strongly turned down also. You can see here, for example, 20, 20, and 6 is going to be 46 in my mathematical universe. And there are only, I can't remember, 20-something species of Triepeolus. So there's a lot of overlap here on these. I have found it to be that useful a character, but it does split out some things pretty well. And here's a note that basically says that Triepeolus mitchelli does not have a female. So it's in the guide, but you get rid of it by clicking on that because otherwise it's just going to linger. Although I think the states that have had mitchelli are listed. So when you click on a state, mitchelli might not be in there anymore simply because it's not known from that region. Like I want to say it's probably a southeastern thing. So Nebraska does not have mitchelli listed simply because the male records haven't been recorded from Nebraska, so it's gone already. You don't have to deal with it. So those are the initial ones. So we can now go to sort of the second tier because there's a lot of characters in here to cover, and then we'll cover a few of the more common species. One thing that, let's see, let's go back to menu and has on this one. So one thing that is tricky is so we'll talk about the pseudopygidial area because Molly has divided that into a variety of patterns that are often tricky to tell apart. Or we should have maybe Molly come in and discuss that, but I'm not sure she's available these days. So what I wanted to do is look at the thorax and the presence of small hairs. Here we go. This is useful, but it's something that is a little confusing because that's not a normal character. So we're looking at the thorax and we're looking on the mesopisternum. So that's the plate that is directly below the attachment of the front wings on the side of the bee. And the pronotal collar would be on one side and the metapisternum would be on the other. There's an illumination here, but it's not very good. And I have a specimen on deck that I'll show you under the microscope. So if you look, this is, again, not easy to see in this particular photograph. So, oops, I did it again. Get rid of that. And in fact, I can't even move this one over. So we'll take it back to here. And I'll show you a picture on screen of a specimen that I have here. So we're under the microscope now. We'll do this at a much higher resolution. Oop, did I do that right? No, it's F. It'll get us there. Here we go. Okay, so most species of Triepeolus. This is a dirty specimen, but it still illustrates the point. We're looking at the mesopisternum here. It curves, there's pits all over it, and it's curving. This is the sternal area, so the underneath of the bee. This is the tegula here. This is the whole segment. This is mid-episternum right there. And this doesn't have any noticeable hairs other than oppressed hairs. So there's oppressed hairs on there. And then in some species, including this one, Triepeolus donatus, they're still small, but they're scattered hairs that are noticeably longer than any other hairs that are on here. And I think she has a couple categories. One is long, and she uses the ocellus as a measurement tool rather than having to actually have a microscope that could physically measure what those distances are. But these are noticeable hairs sticking out from the side. And maybe we'll play with the thing here. And they're not many, and they're just scattered down, and they're only at the lower edges. I'm going to try and move this specimen up a little bit. Not up at the upper edges. So up here, where the wing is attached, those hairs are absent or maybe rubbed off. And then as you go down, here's one, there's one, you start seeing these scattered hairs. And she has 3 categories: none, lacking hairs, greater than 1 lateral ocellus. And those are useful. Let's see, we can do has. I don't know if all these specimens have been scored for all these characters. We have only 5 things that are scored or are, no, these are scored for those. So only 5 have been scored for having these hairs that are greater than 1 ocellus. So those would be relatively long. And then there's a less than 0.5, but still visible. Let's see how many are there. There's 14 scored for that. So, and you're again using the an ocellar diameter as your measuring tool, and you have to make a decision: is it less than half, or is it greater than half? Or, you know, in many cases, it's going to be completely lacking. If we go to lacking, you'll see many more species are scored. So 21 out of, what is it? Again, 29 species, I think. Oops, to get rid of that. Her trick with has, 29 total, is you can't leave any hanging check marks or it will do something and not what you think of it as. So let's go here maybe to the top of the has menu, and we'll look at some other kinds of characters and then try and see maybe under the microscope some examples. So we talked about the downturned ones and the parallel and the width and the swaths on the sides. So this is a tricky one. So here, abdomen, pseudopygidial area, basal hair. So so the pseudopygidial area, these things are the pseudopygidial areas. You'll see another character here further down, which is the shape. So we can look at that a little bit because we'll be seeing these too. So is the pseudopygidial area basically round? So what you're looking at the very bottom here is the edge of the sternites. So this is the edge of the tergites, and this is defining the pseudopygidial area, which is almost always just a dark spot in there, and it's round and shaped. And but also an acknowledgement that sometimes you have white hairs up there, but these are these modified hairs. This is the difficulty, is that sometimes it's difficult to figure out where the pseudopygidial area starts and stops. But you're looking for something out of the norm for just integument, as you can see on either side here. And you have round ones, then you have these quadrilateral where you can make that shape out of the pseudopygidial area. There's actual triangular ones, and then I don't have tanneri, although I have seen at least one specimen of it, which is unusual species, and then triangular. So, oh, sorry, this was oval shaped that I missed rather than round. So you can see this is a little more judgment call things. And so, like a lot of time, what I suggest doing is when you're not quite sure of a character is you play around, click things on, click things off, and then leave them off. Because if you come to an answer for a species without using ambiguous characters, you're way better off. You could say, well, maybe I think this is the best one, but your tone of voice in your mind is like, I'm not 100% sure, but I think it's that one. So the other approach is, well, it's either circular or oval, then you would cover your bets and do them for both. And you say, I know it's not triangular, narrow, or this one. So this is fine. It does eliminate whatever these are in there, and you haven't guessed. So we are guess adverse in using these guides. So back to here, this is another tricky one. So what we're looking at is the pseudopegydual basal hair. So if we bring up one of these are in and probably more clear in Molly's thing. So we have different kinds of hairs in the basal area and the apical. Whether they're always the paler color or not is a little bit difficult to tell, but the implications are that they are. So these are white hairs, those are dark hairs. If we look here to these, we have that there is a uniformity in, so she talks about density, reflectance, and coarseness in the hair. So you don't have two different types of hair, but there's so many little nuance things going on in the sizes, shapes, and patterns of hairs. I found it often difficult to be absolutist about whether these things exist. Again, here's tanneri with its unique little strip of pseudopegydual area, which is hard to define. So we'll leave that. We can look at some of these things. We can look at pseudopegydual areas under the microscope, but I don't know that it's going to be that illuminating. But of course, when you're in dichotomous keys, you can't just skip things. You would have to follow more than one path. So again, pays to do some study, but I can tell you it's been tricky to determine those things, like these shapes things too, except at the extremes. So now, and this is probably something that will take a little time. So we'll look at the sternites, and let's see, I need to, I'm not sure I left no, I guess I didn't. I'm hoping I didn't leave any check marks hiding in there. So lots of characters, some ambiguity. So here we go. So abdomen sternites. So the underside, apical fourth of segment. So we're looking at near the rim. There's a band of white oppressed hairs. So the note here is that the band is often really narrow, not complete, and may exist only in patches on the far side. That's largely what I see in most of these things. We have an explain here, which goes into even more. I mean, that's what it used, but almost nobody ever clicks on it. So here we're just going into more detail that we're just looking at these oppressed pale hairs on the sides, usually of these segments, and that these things are usually quite small. So we'll show a couple here. So if we go in and say, let's look at something that has only. So the categories are none. We won't show that because the absence is easier to illuminate than the presence. So presence on segments 2 and 3, present on 2 through 4, present on 3 to 4, and present on 4 only. So you have all these different categories. We'll do one that should have them on a bunch of them. So let me see if I can pull out lunatus. I'll do lunatus because lunatus is perhaps the most common species. I'm trying to carefully pull these out. In other than remigatus, if you're hanging out in agricultural fields with pumpkins, is perhaps the most common species. All right, so this is good. So we have our lunatus, and we get a good angle here. And we're looking at, I have another specimen on here that I want to put away. This is the donatus, the one with the hairs on the sides of the mesopisternum. Trying to keep my specimens all in a row here. That's the right spot. It is. Okay, so back to lunatus. Let me see if I can get that at a good angle to the microscope. Back to the microscope. Take it down to reasonable area. Got, oh, I can probably get rid of some of this. There we go. All right, so you can already, even though this is not very magnified at this point, you can see a bit of these white oppressed hairs on the sternite. So we're looking at the underside. Here, 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 and here, all these things are white oppressed hairs on the sternites in different patterns. So I believe we're trying to get this, 2 and 3 have white hair bands largely. Remember, we're talking about the apical fourth. So basically near the rim, but probably not right on the rim as is illuminated here. So unlike the oppressed hairs up here and on the rest of the body, these are usually not as, shall we say, dense and obvious. Why they're here or at all, I have no idea. But so here you can see here's white hair bands, white oppressed prone hairs here and here. And so this is S2, S3. Here's S4, absent in the middle, but present at the lateral side. So many, many times, if I recall correctly, you'll find that these hairs are there, but only at these lateral edges. The leg is a bit in the way, but you can see here on this last one, 4, 2, 3, 4, there are white hairs there, but they are quite restricted to the sides, and they're not as obvious as the upper ones. So we're moving to higher power here. And I'm trying to eliminate the shake in this. So there's some reflectance and maybe some goo here, but here are the white hairs, easier to see there. And then on S2, it's a little bit mixed up with what appears to be maybe some kind of dirt, like those things there, contamination, but there are some lateral white hairs in there. So that's what you're looking for when you're looking for those. Sometimes it's really obvious, and again, sometimes you have a specimen that is a little bit messed up. And again, you can choose on Discover Life more than one category if you're not sure, just to be safe. And we want to be non-guessing. Okay, so that's the hair bands there. Now, just looking at my time, I got about 10 minutes. I may not finish all these things. So, so we just talked about those. So now we're back up on the tergites, the color of the hairband. Ah, this is another one that took me a little bit of time. So Molly will call these yellow and white, but it's really, really, really a pale. It's like a dirty pale yellow versus bright, bright white differentiation. And so if you're looking for something bright yellow, you're not going to find it. And it's pretty, again, it's pretty subtle. So let's see what we have here for some pale yellow members. I wonder if remigatus is one of them. So remigatus is classified as having pale yellow, and usually it's some of the white hair bands reflect in the pale yellow category, not all of them. And the last ones are more the bright white. And then this grayish white, we'll find some specimens for those, and you can see the differences, hopefully. But it's another one that every once in a while I have to go like, I'm not 100% sure about this. But usually if it's a pale yellow situation, we are I'm going to take the light level down on this, but this does illuminate things here. So you see one of the characters here of remigatus, relatively small area and definitely not parallel. And if we look up at the top here, can't see it well. There's no white bars there, and that pretty much narrows it down to remigatus. So, but let me change the light level here. Get out, and we will take it down to that. So hopefully, okay, yeah, not bad. So again, we have the processing of the, let's bring this up to full screen. The processing issues here in color rendition through pictures and also on the screen. And maybe I'll try and pull up remigatus there, but this bit of yellowish here and then bright white down there, that's what we're looking at. So already you can see pretty subtle. Let's try and bring up a remigatus picture. Bum, bum, bum. And usually with yellow, you have a set of like yellow to, so you can see like here, Smithsonian's picture, yellowish white. That's not that yellow, but it is a little bit yellow. And if you look at a lot of Triepeolus, all of a sudden you get it. And in general, there's not going to be contrast between the front ones and the rear ones. That, again, I don't really see it in that one. So I wonder if I have any good illustrations. These, yeah, so that yellow area is pretty darn subtle. So sometimes you may not want to use it at all. Let's look at situation. Go back here to this. So the majority. So we're looking at things that are classified as only having grayish white. There's 9 here. Oh, we had donatus, which we just had up there. Do I have anything else here? Literatus. Interesting. So let's see if we can show you something that makes any sense whatsoever on terms of this color with the contrasting all white things. So I think you're getting the point that these are a little difficult to define in terms of white, not white. So look in here, these specimens are a good one. Is it Georgica? Yeah, Georgicus. Okay. So here's one I'm sticking underneath that is defined as entirely white bands. So there should be no shift in the color rendition, and everything should have a grayish white hue. Does that show up for you? Maybe, maybe not. You know, we have some light color rendition of the light bulbs themselves that may be casting a light, but what you're looking for is that these hair bands are all the same color, and it's going to be a grayish white. They're not going to have any yellowish cast. So I'm just
Sam, is there like
illustrating.
any other difference to the quality of the hair? Like a little bit more thicker
Nope,
or plumose? No, totally the
nope,
same.
nope, nope. So again, sometimes it's one of those things that because these are subtle that you want to skip that question and go to somewhere else and then or look at what your options are under those colors and but use it with caution, particularly when you're beginning, because that yellow, not yellow, is pretty subtle. It took me a bit before I got into the fact that maybe sometimes I have to drop that because I can't quite tell if there isn't some pale yellow. We're talking really, as you saw, really, really pale yellow. Okay, Clippius. How are we doing on time here? We got 1 minute here. So with the Clippius, so there's several characters on here that are
I think
useful.
your phone clock is a little fast. It's
Oh,
1:52.
it's 1:52.
Mhm.
Oh, weird. I would think that the phone clock would be governed by the government, but maybe not. Okay, so good. So the Clippius, so in some species you have a, well, this is just length, and we won't go into a lot of details here, but you can see by looking at this that if you measure the um, how much the Clippius projects below the level of the two eyes, you get a notion that you have a long Clippius. So here it says apical rim of Clippius surpassing the bottom edge of the eye by 1.5 lateral ocelli diameter. So again, we're using the ocelli to measure that. And we have something that is more the normal case where it's a lot less. So not surpassing by more than one lateral ocelli. You can see here. So that's pretty straightforward measurement. I frankly don't use that one very much. Let's see what species are involved as having a long Clippius face. Really only one, Donatus. So maybe that's why, because I'm not seeing a lot of differences in there. So this one, though, is used a fair amount, and there's quite a bit of variation on those. It's a relatively, and well, I'll pull up a specimen, relatively good character that can be seen. So you look at the Clippius, and you're looking at a smooth, unpitted, slightly elevated longitudinal midline. So a line going right down the center of the Clippius that's raised, and you can say that's a line versus something that is just like a entire field, as it's pointed out here, of pitting with no line. This one as is illustrating the distinct line going down the middle. And then there's the um, the always present. Well, maybe if I look closely, there is a line. But let's look at a strong line, I think would be good under the microscope and see what we have here. Oh, only 4 have strong lines. Roof thorax, and the rest, I guess, are in the ambiguous. Well, let's quickly look how many are um, added if we add both strong and faint. Well, not that many. So lunatus is one, and often I can see, well, let's pull up lunatus and see if we can see a what's considered to be a subtle line there. I believe I have seen that and used that a fair amount, but lunatus usually keys out pretty quickly. Thankfully, because it is so common. All right, there's our out of focus lunatus face. Clippius is coming into view. And yeah, you can, there's something going on there. It's certainly not like the um, picture we saw for strong, but, and so you can see the ambiguity there, but there's something running down the middle there. And, but not real, not very clear at all in this particular shot and specimen. Let's see if lunatus is also scored for having absent, because you could look at that and say it's not there. And so sorry, I was clicking on only instead of has. So a lot of things are scored for, but not lunatus. Lunatus is scored for having a faintly distinct line only. So a bunch of things are scored for not having it, and a fair number are for having a strong one. So lunatus was shown to have the strong one, but also to have the faintly distinct one, but not the absent one. Oops. There's lunatus again. And, you know, when I was looking at the specimen we just looked at for lunatus, it, you know, you could imagine scoring it for not having that, but it's not, it's scored for only distinct and faintly in that particular category. So I'm wondering now, let's look at, so absent, I think, is not very illuminating. Let's look at as faintly distinct again. Let's see if we can see another species specimen, concavus cressonii. Concavus is a fun one. That's, I believe, yeah, that's the one that's a Cephastra specialist. So many fun bees. Yep, we get rid of this one. Our little lunatus friend. Sure, I got it right. Yep. So concavus now is scored for a faint line. Coming in. I am not seeing much of a line right now. Let's see if we. All right. When I look at that, I see no line whatsoever. Let's see if concavus is scored also for absent.
Why don't you do an only?
I could. Interesting that concavus. Oh, maybe I have. Do I have the male or the female? Oh, I have a male. So let me pull the female here. I'm not sure if I don't recall seeing a character in the reason not for only is I'm interested in sort of ambiguous ones. We could do only. I'm not sure if how many are scored for only faintly distinguishable. To, well, concavus.
Oh,
Okay,
well, there you
so
go. Interesting.
right, so this is the classic faint one, and not scored for distinct or absent. So let's go and see if we can see a faint.
If we can convince ourselves that it's there.
Right. I don't see one. Oh, I should focus.
Oh, you were switching to the female. Never mind.
Yeah, I changed the female. Yeah, the male definitely didn't have one. And let me change the angle. The first impression, though, of that was no line. So I have to go back and look at Molly's thing and see if we have mislabeled the presence of a line. All right, this is the female concavus, and I'm going to say there is no faint line there at all. At minimum, it should be scored also for absent, unless I'm missing something. I'm going to look at it under my regular microscope,
I'm gonna
just
look
in
at
case there's
me.
some lighting thing going on here. Oh, you know what? Yeah, there is a bit of one at the top that was hidden by the goop. I'm going to do a quick goop removal if I can, so I could see where this was coming from. Excuse me while I manicure the specimen. But it's not very, I think it should also be scored for not having one present. All right, I'm going to put it back in and see if it shows up under the light. So if you look towards the top now of the Clippius, I've scraped off a bunch and you can see a faint line there, but certainly it's faint. Eyeglasses on. And it's a little bit tough with this lighting here, but if you look, I think mostly it's a lighting issue. So here's this line here and doesn't really extend all the way in, but this was covered with butt. And so there's a bit one. I think I am going to add it to being absent in the guide though. That's probably all the time we have today for
Yep.
illumination. We can finish it up
You're at
next
time.
time. And are there any
Yes.
questions?
So there has not been. It's been so opened up. Also just as like what's coming up. And sometime this month probably we'll have another Serotina session, and then Lacey Blossoms are going to be joining us in September. So that'll probably give us just enough time to finish off this and the Serotina, right? So
Yeah, I mean, we jump around a lot, and then we'll try and get Tom Ornifurco for Epeolus at some point, and yeah, bring in more guests, and then who knows where. I mean, we've got Lazy Blossom. We'll see how far that goes and how much detail Joel and Jason want to get into, but there are a lot of species there, a lot of subtlety between some of those
yeah,
pairs.
I'm not sure how long they want to be coming every week. Well, I
Yeah,
think that'll
that's
be
what
an
I'm thinking
emerging
too.
conversation.
Yeah,
Yeah. Did they just sign themselves up for 3 weeks worth or 3 months, 3 years? They don't
yeah,
know.
yeah. Who knows? I mean, we still can get into a lot of the small groups of Andrina, Trachandrina, the
Mhm.
Melandrinas, and there's a within those are a bunch of hair pullers, and maybe Mike and I can delve into those. It's sort of endless, isn't it?
Kind of,
But
yeah.
there are 800 species east of the Mississippi.
Okay. Well, I'm
All
gonna
right.
stop the recording. Great week.